The next step in our pseudo library named HAL Handy Array Library is going to implement the functions that relate to sorting those int arrays. So before we jump into the code, we're going to discuss a little bit about what we're going to do, which is always a good idea, by the way. Sketch out your algorithm on paper before to implement them, design them before to implement them. So the first thing we could do is we could go back to the reading assignment, and the textbook is kind enough to provide for us already a solution to the sorting of an array problem in the form of the bubble sort algorithm. So if you haven't already, pause this video, go take a look at this. Now that you're back, hopefully you went, and if you had questions, you posted them on the forum, Piazza, etc., came to office hours. You should have, before to continue this video, you should have a decent understanding of how the bubble sort is doing its job. Okay. So what we're going to do, instead of just re-implementing again the bubble sort, because if we do that, I mean, most of the time what's going to happen is that it's only your memory that's going to get a workout because you saw a solution, you saw the code, maybe you played with the code, typed it out, tinkered with it, etc., which is the best way to learn programming, right? And now it's up there in your mind. And if I ask you to recode a sorting algorithm, naturally you are going to rely on your memory and you are going to reconstruct that one solution. What I would suggest we do instead is try to come up with a different algorithm to sort an array of int. And again, what I tell you about array of int is going to work with any array of a numerical data type, like double, float, long, etc. Okay. So how do we come up with our own algorithm? Well, that's the part that's going to be interesting. That's the part that's really problem solving in programming, right? So I'm going to try to show you how to break down the requirement. I need to sort an array to come up with a potential solution. And it's not going to be a very efficient sorting algorithm. Actually, it's going to be one of the worst sorting algorithm, just like the bubble sort. Okay, these are not very efficient at all sorting algorithm, but it's still going to solve the problem. And at the level of this class, this is just to get you started designing your own solution to algorithmic problems. So this is actually good practice. Let's start by considering, I don't know, an array of 3 elements. Okay? How do I make sure that an array of 3 elements is sorted? Well, but I want, assuming that I'm sorting in ascending order, okay, what I want is the smallest value to be at the front. Then I want the second smallest value out of the 3 to be in second position, and then I want the third smallest value to be in third position. Well, it's true. This is exactly what I'm looking at, okay? But that doesn't help me, formulate an algorithm. So let's keep brainstorming here. This element here to be the smallest should be lesser than this one, the one right next after it. And it should be also smaller than this one. Okay. So if I make sure that those two conditions hold true, the first element is smaller than the second, and the first element is smaller than the third, then I know that this first element is in its rightful position here at the front of the array. And when I'm done assessing that, well, I'm done with that first element. I don't need to worry about it anymore, right? So I could just ignore it and focus my attention on the second element. What are the conditions that need to be true for the second element to be in its rightful place? Well, it should be lesser than the next element. If I add more elements here, like a fourth element here, right, I would have to say again that this second element need to be also lesser than the element after, right? So I can scale this up to actually, there we go, I'm putting the missing arrow here. I can scale this up to 4 elements, so I went from 3 to 4 elements. The rule seems to be repeating themselves, okay? For this first element, I was comparing like this to the next, the one after, the one after. For the second element, To make sure that it's in its rightful position, I compared it to the element right after it, then the one after it, then the one after it. And then finally, what about this guy here? That's the third element, right? Well, I need to compare it to the element after it. And that's it. Okay, so for an array of 4 elements, if I do all of those comparisons, then I'm good. And I don't know why this disappeared. I'm going to try to bring it back. Or not. Well, my array just obliterated itself. There is no undo. Nice. We're going to call this a feature, not a bug. Okay, so before to disappear gruesomely, my array was telling us actually that we needed to do a certain number of comparisons, right? And there was a structure to those comparisons. So let's try to reformulate that differently. So for each location I in my array, okay, for each element at location I should write, but I'm trying to keep it a little short on the screen, okay? So for each location I, which means that I is going to vary between 0 up to whatever the size of my array is, minus 1 included, okay? So for each location I, meaning like I'm considering this guy, then this guy, then this one, then this one, okay? I'm going to look first and make sure that this element is at its rightful position. Then I'm going to look at this one. Then I'm going to look at this one. Then I'm going to look at this one. That's what I mean by this first for loop. Okay. So what do I do every time? I compare, and I'm going to call my array data, okay, for the sake of this algorithm. I compare data index I with what? Every over element in the array. Okay, so every other element at position or location, I'm going to call that location J. Is that true actually? Well, let's see. When I'm checking this first element here, so for I equal 0, okay, we're looking at the first element of the array. I compare it to this one, I compare it to this one, I compare it to this one. Yes, it's true. Compare it to every other element located at location J. Every over element. I don't compare to myself. Okay, first thing to notice. And then, is it true also for the second element? Well, let's take a look. The second element here, I consider a second element. What I did is I did a comparison like so and like so. So it's not, there is no comparison backward, okay, because I already did the comparison backward. So I don't really compare myself to every single over element in the array. I compare myself to every over element in the array that comes after me. Okay, this was true also for the first element, this is true for the second, this will be true for the third. Okay, so every over element at location J, but then I'm going to say that location J is going to be in the range I plus 1, size minus 1. Okay? So it's every other element at location J located after this element at location I. What do I mean by compare? Well, let's elaborate a little bit on that, okay? Comparison means there's going to be an if statement somewhere, and that if statement is going to check whether the elements are in correct order. So I'm going to expand what I mean by compare here. I'm going to have an if statement, and this if statement is going to say if data index I is, so if it's lesser than data index J, we are good. We are like doing ascending order. So I'm going to not be interested in the case where things are okay. I'm going to be interested in the case where things are not okay. If data index J is greater than, data index I is greater than data index J, then those two elements are not in correct order. So I'm going to report an error. And that's pretty much my algorithm. So instead of saying compare data I, blah, 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 with every other element, I'm going to say for, there we go, for every other element at location j with this range, then compare with the if. Let's see if we can actually, no, we cannot do that. Never mind. Yeah, okay, never mind. I was going to try to reindent and move this, but this is not going to be like to be working too well. Okay, so we have everything we need here, except that this is just an algorithm to tell us if the array is in order. How do we go from this to an algorithm that allows us to put the element of the array into correct order? Well, the logic should be somewhat similar, right? So I'm going to look at this first element here, okay? And I'm going to compare it to every other element. So if I compare and I figure that this is lesser than, that means relatively to one another, those two elements are like in correct position, okay? And this one should be definitely before the next one that we're checking here. When I compare to this guy, if I figure out that there is a problem, that this first element is bigger than this one. For example, here I have a 9, here I have only a 1, okay? If I find out something like this, then the solution is easy. I want to swap those two elements, okay? I compare them pair by pair, and if I figure out that the first one here at the start of the array is not the smallest one, I'm going to swap it around with this element here. The 9 is going to go there, the 1 is going to stay here. And now the comparison is favorable, okay? This element is also smaller. So we already checked the first one, it was smaller. The second one is smaller. What about comparing ourselves to the last element here? Well, let's say that we have, again, something that is smaller here, like a 0. Well, that won't do. So every time I detect an error, right, I'm just mitigating it by swapping the 1 and the 0 here. So the 0 ends up in this element, the 1 ends up in this element, and now we have made sure, after going through all of those comparisons, we made sure that the element that is going to be actually at the front of the array, 0 in this example, is the smallest of the lot. Okay? All right, so that means what? That means that we can get rid of those scribbles here, and we can fix our algorithm a little bit. And I can say if they are not in order, then swap data index I with data index j. Okay? That's good enough. We have a good enough outline of an algorithm that we can actually jump into the coding knowing kind of what we are doing. And this is very important to have this broad, guideline pretty much before to start coding. I say kinda because, I didn't put much thought here into whether I needed to go from 0 to size -1, or whether I really needed to go from I+1. That one I'm pretty sure, yeah. But should I stop at size -1? Should I stop before? Like, should I stop at size -2 here? Try to think about those problems, okay? Pause the video. Before to go any further in the coding, try to refine this algorithm to make sure that you don't have this off by one error that is all too common when we use arrays, okay? Then we are going to jump into the implementation, and then I'll come back and discuss the specific thing, okay? But trace this algorithm, try to see what happens when you are at the extreme value of your index. Make sure that it actually makes sense. All right, now let's jump into the coding. So we want to implement a void int array sort method. It still takes an array called data as parameter with its size. So I'm adding this to the hal.h file first thing. Okay, so here's a prototype of my function. And then I'm going to go to hal.c and I'm going to implement it, why not, at the front here. Okay, so here's the space for the code for my function. So I want to implement exactly the algorithm that I described. Okay, so we had two nested for loops, two nested loops, counter control loops inside one another. So I'm going to use for loops. Okay, here's the first one, and outer loop. And then inside of it, there's going to be another one, and inner loop. And I'm commenting here so that I know exactly what the curly braces are closing, right? The first one, I'm going to use index I, like I did in my algorithm. Int I equals 0, I lesser than size. So lesser strict than size is the same as lesser equal size minus 1. Okay, so that's again aligned with my algorithm. I++ at the end of each iteration. For the inner loop, I'm going to do int j equal I plus 1. That's what my algorithm told me to do. J lesser than, again, size, j++. And then this is where I have my if statement here. If I detect that the elements are not in order, then I'm going to swap them around. So if data index I is greater, so I'm assuming that I want to sort in ascending order. So smallest value, then a small value, then a less small value, bigger, 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 etc. That's the order that I want. If I wanted to do the opposite, then this is where I would have to make some changes in my algorithm. Okay? In my algorithm and in my corresponding implementation. But for now, I'm only focused on sorting in ascending order. So if data index I is greater than data index j, those two things need to be swapped around. So I don't have a swap method, a swap function handy, okay? Swap function or macro or whatever. So I'm going to just write it like this. I'm going to say int tmp equals data index I. Data index I equals data index j, and data index j equals tmp. That's the 3 lines of code that I need to swap the content of two variables. So here I'm swapping the content of the element in the array at index I with the element in the array at index j. Okay, well, that looks pretty good. So I don't need that extra space here. As a matter of fact, I don't even need those outer curly braces here because there is technically only one statement inside my outer for loop, which is this entire for statement here. This entire for statement, the inner statement, has also one statement only, if statement. It's a composite statement, but it's only one statement. So I can even remove those curly braces here and clean up a little bit my code. All right. What else do I have to do? I don't have to return anything from this function. I just go ahead and modify the element in the array. So let's see first if we can get this to compile. So GCC, here, let me be lazy, test.c, hull.c. So compilation is okay, no problem. Now let's test it. So how are we going to test this function? So different ways we can test the function. We have already here some code that is reading an array and displaying it back. Okay. Let me start cleaning up my test.c because I don't like the way that we are dumping everything in the main. Let me isolate things in functions, like for example test int array display. Okay. I want to call a function test int array display and have it pretty much do what I'm doing right now by hand here. Okay. So I'm going to go ahead, implement it here. And I'm going to say this is void test int array display. And what I want it to do is I want it to display, I'm testing int array display, and maybe like space it out so that I can tell apart my test more easily in the output, and then declare an array and then display it on the screen, and that's all I want it to do. Okay, so easy stuff here. I need a prototype. Here we are. My colon here, and I can get rid of this. Similarly, I'm testing int array scan here. Awesome. So let's call a method test int array scan. And I'm going to take all this and I'm going to paste it in a function test iterate scan. Void test iterate scan. Open curly brace. Close curly brace. And because I have actually encapsulated that into a different function, I need to redeclare my array here inside that function. Okay. So testing iterate scan, declare an array, read it, display it back, and we'll do visual inspection to make sure that this is correct, like we did before. Let's put the prototype before the main. And remove what is no longer necessary inside the main. So I did refactoring here. I didn't change at all what was done in the code. I just changed the way that I wrote it. So let me make sure that I will have, like, for example, a missing closing curly brace or something like that. So on line 34, expected declaration, blah, blah, blah. So let's see what this is about. Expected declaration statement at end of input. Probably forgot to close something somewhere. Let me take a look real quick. This is it here. I opened a curly brace that I should not have opened, and so therefore there was a closing curly brace missing somewhere or something like that. So I replaced that by a semicolon, save, compile again. This time it's compiling. So if I run it, I get the same stuff, okay? Testing int array display, testing int array scan, enter the value of the element, 9, 8, 6, 5, 4, 3. I will have to make this smaller if we keep using it, but I can comment it out easily, so that's not a problem. And at the beginning of each method, each function here that says what it's going to test, I'm going to put a backslash n to space out things again. All right, so now I can go and I can say, well, the next thing I'm going to work on is test int array sort. Okay, I want to test the int array sort. I'm going to say this is the prototype I want for this this method, this function. Void, and I'm going to implement it after the end of the main here. All right, so I talked about doing a first kind of test, okay? A test where I would actually read an array from the user and sort it. So it's a very generic test. It's an interactive test, okay? So I can already go here, for example, and say, you know what, I want to read this array here. And by the way, when I scan an array, I don't need to initialize it, but anyway. I'm going to take the code that I had here in the scan testing function, and I'm going to say I want an array of, let's say, 4 elements. Keep it a little shorter, since we're going to have to re-enter it every time we test, okay? I want an array of 4 elements, testing array, int array sort, and I'm going to say I want you to read an array of 4 elements, then I want you to display it back just to make sure it's okay. Then I want you to sort it. And once it has been sorted, I want you to display it once again. So, original version. No, original array. And I put some spacing here everywhere. Original array is this. And then we're going to say sorted array. So we sort it, and then we display sorted array, and here we are. All right, let's get rid of some typos, computation error, etc. Ooh, yeah, we have a bunch. So error expected equals sign here. What is it? Line 23. Int my array. Yeah, this is just a typo. Easy enough. Let's get rid of that. GCC. Okay, that was the only problem. pretty cool. Run this. Oh, so before we run it again, Control C to interrupt the execution of the program in the console, okay? And then before we run it again, we don't need to retest constantly those guys. So I'm going to comment them out for now. When I want to run the entire set of tests, I will uncomment them. But for now, I don't want to go through entering a 10-element array every time I want to get to actually the test that I'm focusing on right now. So I want an array of 4 elements. Well, if I have 1, 2, 3, 4, okay, the original array is 1, 2, 3, 4. The sorted array is 1, 2, 3, 4. Okay, fair enough. What if I have here something a little different? So 4, 3, 2, 1. So 4, 3, 2, 1 sorted into 1, 2, 3, 4. Looks like it's working, at least on that test, okay? And then I would like to do things like, for example, 1, 3, 2, 4. 1, 3, 2, 4 is still sorted in as 1, 2, 3, 4. Perfect. So I could keep going like this, okay? So the idea is I want to be able to interactively test things like that and potentially change the size of the array. But I would like also to have another interarray sort function that kind of go over a bunch of automatically generated arrays of a certain size and let me know whether they are tested correctly or not, okay? So I'm going to be able to do like half of that work for now. So let's rename this test interarray sort 1, and we are going to create another function called test interarray sort 2. And that one is going to be a little bit more automatic, like I was saying, okay? And we are going to, next video, next exercise, we're going to have even more tools to make it even more automatic. So for now, I'm going to comment out the first version here. We don't need to call it back again. And I want to do some more automated tests here, where I generate the arrays pretty much automatically. So what am I going to do here? Well, I want to make things a little smaller. I'm going to focus on arrays of size 3. So I want to create a bunch of arrays of size 3, and I want to call every time the interarray underscore sort function on each of those arrays. And then I want to make sure that it's actually the right solution that I got, and display something that's going to let me know that it was not the right solution, you know, if it's different. So to do that, like I said before, we need like one of the functions we're going to implement in the next video. So what can I do for now? Well, I could simply display on the screen, you know, okay, this is original, this is the sorted array, okay, and that's it. And let the user do pretty much a visual inspection. So I already have some code to do this, okay. I can grab all of this, and I can say, there we are. I'm going to display, this is my original array. This, I'm sorting it. This is my modified array. Very well. But I'm doing that always on one array called my array. So what if I wanted instead to have something called my test arrays plural? And I want inside this array to have a bunch of array of 3 elements. And these are going to be all the arrays of 3 elements that I'm going to test my function on. That's starting to sound like a matrix. Okay, a matrix that would say I have a certain number of rows. Each row is an array of 3 int elements. And when I'm calling my interarray sort function on line 27, I don't want to pass the whole thing. I want to pass my test arrays, and I want to pass only one specific row, like the first row, then the second row, then the third row. And from the interarray sort perspective, that means you give me a row, you give me an array of 3 elements. I'm going to sort it. You give me another row of a matrix, but all I see is an array of 3 elements. I'm going to sort it for you. So we're going to use this here to modify a little bit the code that we had and say I want to display the thing that I'm about to sort. I want to sort it, and I want to display it after it has been sorted. Okay, that's all good, but I need to initialize this, and I need to probably use a loop here. Okay, a loop that's going to say for int I equals 0, I lesser than number of tests, I plus plus. And then open curly brace, close curly brace. This is what I want to do in my loop. Okay, in my loop, I want to display, I'm about to sort this array. I'm sorting the array. Here is the sorted version, and visual inspection for now, just visual inspection to make sure that it was sorted correctly. Okay. What else? Well, I use NB test here. Okay. So NB test is pretty much the number of rows of this matrix. So I might as well do something like this, NB. Well, if I do, yeah, I'm going to make it a constant, NB test. Alright, and I'm going to say const int NB test equals, how many tests should I do? Well, if I use arrays of 3 elements, okay, there are 6 possible permutations. So I'm going to go with that. Okay, that's why I took an array of only 3 elements. I'm going to go with that, and now I want here to have all of those possible permutations. So let's say that I have values 1 to 3. Okay, well then I want to have 1, 3, 2. And then I want to have to start by 2, so 2, 1, 3. 2, 3, 1. And then starting by 3, 3, 1, 2. 3, 2, 1. Okay, these are all the permutations. Okay, so I have here a matrix that contains all the arrays represented by rows that I want to feed to my sorting algorithm, one after the other. Okay, so after that, I iterate over all of those elements, and I feed one by one those rows to my array. Let's save. Let's get rid of compilation error. All right, implicit declaration of function, yes, this is actually the prototype that needs to be updated, and this is also bad. This should be sort and then the parentheses after it. So let's fix that while we're at it. Sort 1 is going to be this one. Here we are, and sort 2 is going to be this one. So we have prototype for the 2 function, GCC. What else is going wrong? So we have a problem here with variable size object may not be initialized. Okay, so we have a problem here with the initialization of our 2-dimensional array. I'm going to say that this is going to be unspecified. Okay, I'm going to keep this because I want to use it in the loop, okay, instead of hard coding the value 6 everywhere. But I don't need actually to declare the first dimension for this array. So I'm going to not declare it. There we go, the compiler is happier now. And then I'm going to run this a.out. So stack machine detected, so we have a Stack Overflow, our loop is off by something. We're going to check this out, okay? Original array, 1, 2, 3, 1. Sorted array, 1, 1, 2, 3. So we are working with arrays of size 4. That's the problem, because what I gave is an array of size 3. So I'm going to go here, change that. And this is what caused actually our stacks machine here too. So run it, and this looks a lot better, right? Original array 1, 2, 3. Sorted array 1, 2, 3. 1, 3, 2, 1, 2, 3. 2, 1, 3, 1, 2, 3. So we always sort back to 1, 2, 3, no matter what is the permutation that we throw actually at our sorting function. I'm going to fix a little bit here the backslash n so that it doesn't display. What am I doing here? Yes. So that it doesn't display blank lines in between. We're going to rerun that real quick. So it's just purely aesthetic, it doesn't really matter. But there we go. It's a little bit more readable. And you can see here that we have a test that is interactive, we have a test that is enumerative, okay? We could do the same thing with an array of size 4, just to go a little further. But this is kind of how we are going to organize our tests from now on in this course, okay? Some of the tests are going to be interactive. Generally, we're going to put those in the main.c part of the code, and some of the tests are going to be actually automated, and this one is only semi-automated, but we're going to fix that in the next video, and those are going to go in the test.c. All right, we're going to wrap it up here for this video. As usual, you know the drill. Post on forum, Piazza, whatever we use this semester if you have any question, or even better, come to office hours, and the TAs and I will be glad to address any of your questions. All right, see you in the next video.